Good afternoon, welcome to my YouTube channel. This is your mathematics tutor, Mr. Kanindima. Today we're going to do on coordinate geometry on 2016 paper 1, and the question is as follows. The line is a line cuts on the x-axis and the y-axis at A and B respectively. Calculate the coordinates of the midpoint of A and B. So we all know that if it cuts on the x-axis, y is always 0, then on the y-axis x is always 0. That is according to the rule of coordinate geometry. So for the x-axis it's for A, then the y-axis is for B. This is why here I've written them like this. So on the x-axis y is 0. We have y is 0, and on the x-axis that's where A is. On the y-axis x is 0, and that's where B is. So we are looking for the value of y. So we'll start. So where there is y here, we are putting 0 to find the value of x. So it will be 2, 0, then plus 3x is equals to 12. Then it will be 3x, which is equals to 12. We divide 3, and then our x is 4. So we put there 4. We are finding first the coordinates for us to find the midpoint. Then we also come here, we say where there's x, we're putting 0, 12, then 2y plus 0 is equals to 12, which is 2, then over 2, then y is equals to 6. So therefore the coordinates that we have are 4, 0 and 0, 6. Then that's where now we can find the midpoint, because here they need the midpoint of A and B. The midpoint, the formula is midpoint is equals to x1 plus x2 over 2, y1 plus y2 over 2. Then we have x1, y1, x2, y2. Then we replace. It will be x1 is 4 plus 0, over 2. Our y1 is 0 plus 6 over 2. Then it will be m is equals to 4 over 2, then 6 over 2, which is our final answer will be 2, 3. These were the midpoints for A and B. The second question is this one, B. In the diagram below, this is the trapezium. They're saying AB is parallel to DC. Don't forget about this note. AB is parallel to DC. So it means they have the same gradient. Then A as a 90 degrees. The coordinates of A and B are these. A and B and D, sorry. Those are coordinates. Then respectively, the equation B, the equation of BC as an equation, which is this one. Then we've been told to find the equation of AB. Now for us to find the equation of AB, we need to find the gradient of AD, because AB and AD are perpendicular. So we're going to start. We need first the gradient of AD. So we're going to start. So we're going to find the gradient of AD, because we have said AD and AB, AD and AB are perpendicular. So we are going to start. This is our x1, y1, x2, y2. Then our y2 is 8 minus 4, then over x2 is 2, then minus negative 4. We are going to get a 4 over negative times negative, it is positive, so here it will be 6. The factors of the number that can enter into 4 and 6 is 2 into 4 to give us a 2 over a 3. So this is the gradient for AD, remember. But the examiner wants you to find the equation of AB. The examiner wants the equation of AB, but we found the gradient of AD, and AD is perpendicular to this. So we're going to change the gradient by, we all know that if a line is perpendicular, we'll change to m1 times m2 is equals to negative 1, where our m2 is 2 over 3, then times m2 is what we're looking for, which is negative 2 over 3, then it will be negative 3 over 2, because we're multiplying the reciprocal of 2 over 3, which is 3 over 2 both sides. Which is, we are getting this one. So this is the gradient we're going to use for us to find the equation of AB, because they want the equation of AB. So this is our gradient, and these are our coordinates for A, because we're finding the equation for this when this line is perpendicular. So this is what we are going to do. So we're going to write our formula y minus y1 is equals to m2, because we're using m2, x minus x1. Our y minus y1, this is our x1, this is our y1. So our y1 is 4 is equals to, then our m2, which is negative 3 over 2, then x minus negative 4. This is what we're going to get. Then here, if you want, you can cross multiply, or you leave it like that. So you can cross multiply by saying 2 times to give us 2y minus 8 is equals to negative 3x. Then we are going to get negative 12 like this. This is what we're getting. This is what we're getting. From here we can say 2y is equals to negative 3x minus 12 plus 8. 2y is equals to negative 3x, then minus 4. From here you are done in finding the equation. From here you are done in finding the equation, or if you want, you can now divide the 2 in both sides to find final. But from here you are done. Or you can say, when you divide the 2, it will be y is equals to negative 3 over 2x, then minus 2. But from here you are done. We come to number 2, find the equation of DC. Remember the note, AB is parallel to DC. AB is parallel to DC. It means the gradient for this one is the same. So according to the question, AB is parallel to DC, and remember we had found the gradient for AB as this. This was for a perpendicular, but for parallel we all know that it won't have a negative, and the coordinates that we're using are 2, 8, the ones for D. We're finding the equation for DC, and then the statement says AB is parallel, and parallel, the equation, the gradient for this one was -3/2, but since it is parallel, it will be 3/2, which is this one now. So we're going to replace our y minus our y1 is 8 is equals to 3/2, then our x minus 2, then we cross multiply, it will be 2y minus 16 is equals to 3x minus 6, then 2y is equals to 3x minus 6 plus 16. Then we're going to get 2y is equals to 3x plus 10. You are done. That was the equation for DC. That was the equation for DC. Come to the last one. We're finding the coordinates of C. So for us to find the coordinates of C, we're going to connect BC, the equation for BC and DC. So this is how it will look like when we connect the equation. So for us to find the coordinates of C, we are connecting the equation of BC and the equation of DC. So this is the equation of BC, then this is the equation of DC, the one that we had found. So now when we do, we have to make y to be subject of formula. Even this side, it will look like this. When we divide the 4 to be 7/4, then x minus 4 into 8, it becomes a 2. Then here we're making x to be, y the subject of a formula. We'll divide 3 both sides. Then we are now going to equate each other. We are going to make this, because they are intersecting at a point which is C. They are intersecting at a point which is C. So they are going to be equal to each other. Then now our main objective here is to find the value of x. So like terms together, this will follow this, 2 will come this side. So we're going to have 7/4x, then it will be -2/3x is equals to 20/3 plus 2. Introduce 1. Solve them as fractions. We introduce our common denominator here is 12. 4 into 12, that is 3 times 721x minus 4 times 2 is 8x, then is equals to, we do the same within this side, 3, then 3 into 1, that is 3 into 3, that's 1 times, to give us a 20 plus to give us a 6. Then when we do our mathematics, we are arriving at this stage, 21 minus 8 to give us 13x over 12 equals to 26/3. We cross multiply from here. What are we going to get? So when we cross multiply 2 times 13x, it will give us 39x. Then 12 times 26, we're getting 312. Then we divide 39 to find the value of x. Then when we divide, we're going to get 8. This is the value of x. Now what is the value of y? So for the value of y, you can get any equation that you want. You can go with this, you go with this, the answer has to be one and the same. But me, I'm going to go with this. So I'm going to write my equation. Y is equals to 7/4 x minus 2. Where there's x, I'm putting 8, because the value of x was found 8. 4 here, 1, 4 here, 2. 2 times 7, that is 14, minus 2. Y is equals to, what are we getting? 12. We're getting 12. So therefore the coordinates of C are x is 8, then y is 12. Even if you use this formula, the answer has to be one and the same. Shalom, shalom. Thank you for watching.